Welcome back, fellow space enthusiasts. Today, we embark on an awe-inspiring journey that will take us beyond the boundaries of our own planet and into the captivating depths of the cosmos. In this episode, we delve into the enigmatic wonders of our universe. We inhabit a galaxy known as Milky Way, which contains hundreds of stars. How did we arrive at this point, and what is our future? These concerns involve galaxies in every aspect. The known universe contains 200 billion galaxies, each of which is unique, immense, and dynamic. Where do galaxies come from? How does they work? What is their future, and how will they die? Let's discuss about today's subject. This is the Milky Way, our galaxy, approximately 12 billion years old. The galaxy is a vast disk with enormous spiral arms and a central nucleus, and it has one countless galaxies in the universe. Galaxies are massive assemblages of stars. First and foremost, a typical galaxy could contain 100 billion stars. Outside of our galaxies, we can spot vacant or empty space. They are called stellar nurseries, the locations where stars are formed and perish. The stars in a galaxy are formed in nebulae, which are concentration of dust and gas. Our galaxy contains billions of stars, many of which have planets and moons orbiting around them. But for a very long time, we knew very little about galaxies. A century ago, we believed that Milky Way was the only galaxy in the universe. But here comes big changes when astronomer Edwin Hubble altered the entire situation. Hubble observed the universe using the most sophisticated telescope available at the time, the 100-inch Hooker on Mount Wilson near Los Angeles. Far, far away, he saw hazy masses of light in the darkness of the night sky. He realized they were not even separate stars. They were entire star-filled cities, constellations far beyond the Milky Way. From this, the astronomers received an existential idea of unexpected. We went from Milky Way galaxy being the only galaxy in the universe to billions of galaxies in a single year. Hubble made one of the finest discoveries in the history of astronomy when he discovered that the universe contains many galaxies rather than just one. Let's check some of examples. First, this is Whirlpool Galaxy. It comprises over 160 million stars and is characterized by two enormous spiral arms. Secondly, in addition, the stars of the huge elliptical galaxy Mide. 7 shine with a golden hue since it is one of the oldest galaxies in the cosmos. Third, now look at the Sombrero Galaxy. Its massive bright core is surrounded by a cloud of gas and dust. Besides that, all the galaxies are very beautiful. They stand in for the fundamental building block of the cosmos. As they spin across space, they resemble enormous pinwheels. Galaxies are enormous on a grand scale. On Earth, we measure distance in miles. For space, we use light years. Our galaxy's diameter is over 100,000 light years, and we are now located at 25,000 light years from its center. While the Milky Way seems enormous from Earth, when we compare to other galaxies, it is rather little. We can compare by the snow galaxies like Andromeda. The galaxy closet to us is about 200,000 light years wide, making it twice as large as the Milky Way. M87 is the largest elliptical galaxy in our own cosmic backyard and much bigger than Andromeda, but M87 is tiny compared to this giant 6 million light years across known as 1101, the biggest galaxy ever found, which is approximately 60 times the size of our own Milky Way. It is common knowledge that galaxies are enormous and ubiquitous. But why is this the case? The origin of galaxies is a key mystery in astrophysics. Approximately 13.7 billion years ago, the universe began with what we refer to as the Big Bang, a period of intense heat and density. We know that there could not have been anything like galaxy at that time, so galaxies must have come from that very early universe and formed from it. For stars to form and for galaxies to form from those stars, gravity is essential. After the Big Bang, the first stars began to emerge only 200 million years later. The earliest galaxies formed as their masses began to clump together due to gravity. Thanks to the Hubble telescope, we can now see the early universe when galaxies were just beginning to form. The light we see from distant galaxies now, however, really departed those objects many millions or perhaps billions of years ago. What we see now is the distant past of those galaxies since it took so long for their light to get us. The Hubble Deep Field reveals a collection of fuzzy dots. They are quite different from the galaxies we see now. We hardly make out these little specks of light. Those fuzzy patches of light are really millions or billions of stars beginning to combine. The oldest galaxies are represented by these barely visible blotches. They began to take shape around 1 billion years after the Big Bang. Whatever we discussed a little earlier about the tiny specks of light is the ends of visible range for Hubble telescope. However, a second sort of telescope, one too large to send into space, is required if we are to travel much farther back in time. Not only can the telescope identify primordial galaxies, but it can also trace their evolution. The evolution of galaxy and galaxy cluster formation may be followed. All the galaxies that have developed since the cosmos was just a few 100,000 years old are leaving their imprints for us to observe. Finally, scientists can begin to answer the question, what did young galaxy look like? Galaxies have evolved from cluster of stars to the complex web system we are seeing today, and this process is being seen by astronomers. As far as we can tell, the greatest structures in the universe today originated as stars clusters, evolved into galaxies, formed clusters of galaxies, and ultimately coalesced into superclusters of galaxies. There's a lot of stardust, gas, and clumpy structure in the early galaxies. However, modern galaxies seem organized and tidy. Always the question raised, when and how can tangled clusters of galaxies become neatly organized spirals and pinwheel? The explanation to this phenomenon is the gravity, as galaxies are molded by gravity and its effects determine their fate. Therefore, at last, we can conclude that it is fact that at the center of most galaxies lies an unfathomably strong and destructive gravity.